We're going to look at the transformations of exponential functions. So if I take a look at just the basic function y equals 3 to the x, let's see if we can type that in here. You're going to see that sort of a hockey stick shape. It starts low here and then goes up quickly, and it's going to keep on going out. We can talk about the domain of the function going from negative infinity all the way over to positive infinity. And we can talk about the range. The lowest y value gets very close to 0 and then goes up to infinity. So in our normal exponential function, we have a domain of all real numbers. We have a range that goes from 0 to infinity. And we also have a horizontal asymptote that has the equation y equals 0. And you can take a look at that in this picture. As it goes out to negative infinity, this line will get closer and closer and closer to the line y equals 0. If we add 2 to the function, and it's outside of the function, and let's change that to plus 2, you'll notice everything moves up 2 units, and it still scoots, up quickly. So for this one, it still has a domain of all real numbers. And again, you can check that out by just looking at the function. There's no fractions and there's no square roots in the problem. The range, however, has been adjusted. The lowest y value that it can approach is the number 2. It doesn't actually touch 2, but it gets really close to it. That's because it has a horizontal asymptote at y equals 2. However, if we put the plus 2 inside the function, and again, this one, everything got shifted up 2 units. If we put the plus 2 inside the function, and to do that, I need to use parentheses. All right, so I need to put it in parentheses so that my calculator knows that the x plus 2 is what's in parentheses, or up in the exponent, so that it does do this graphing. If I graph this, notice it still starts low and goes up, but it's been shifted over 2 units to the left. The domain is the same. It's still negative infinity to positive infinity. No matter if you shift it further to the left or the right, all your x values will be covered. The range, however, goes back to 0 to infinity, not including 0, because you have a horizontal asymptote there. And in this case, you shifted left 2 units. So we still have if it's outside the function, it's going to shift up or down. That's going to impact your horizontal asymptote. If it's inside the function or inside the exponent, that's going to shift you either left or right, and that doesn't affect the horizontal asymptote. However, this negative sign, if I put a negative in front of the function, so I'm going to come in here and delete this stuff out. And let's take care of that. Alright, but insert a negative in front. Okay, the base is still 3 to the x, but you've multiplied it by negative 1 in front. It's a flip around the x-axis. So you reflect it about the x. Instead of opening up, it opens downward now. The domain, still negative infinity to positive infinity. You can use all x values in this function, but your range now has been changed. Your range is going to start low, all the way down to negative infinity, but go up as high as 0. Notice it goes from negative infinity, all your y values, all the way up to almost the number 0. The horizontal asymptote is still y equals 0, only now your function is approaching it from the bottom side of y equals 0. And this was a reflection about the x-axis. Okay. If you put the negative inside of the function, inside of the exponential, so we'll delete this one out and insert a negative in the function and our function being an exponential, so it's inside the exponent, and I graph this, notice now the hockey stick went the other direction. Now it's going high down to low. It got flipped around the y-axis. Still the domain is all real numbers. Your range still goes from 0, not including 0, to infinity, because again you have a horizontal asymptote at y equals 0, but you reflect it about the y-axis. So if I put a few of these ideas together, and I have p of x equals a negative 3, x minus 2 minus 5, I can talk about how this gets translated by looking inside the function first. The minus 2 is going to go to the right 2. This negative in front, remember, tells me that I'm going to reflect about the x-axis. And then the minus 5 is going to tell me outside the function, that's going to be a shift down. This one was shift up, plus it was plus 2. Then this is minus 5, so you're going to shift down 5. Okay, so that's transforming the exponential function. If I change the base, instead of 3, I make it, for example, 10. So let's call it k of x equals 10 to the x. We can see how that changes. If I have just a 3 to the x, and I change it to 10 raised to the x power, and I can make it a little darker here, and then go ahead and graph this. So the first one I type in is going to be 3 to the x, and it just kind of starts out and goes up pretty slow. The y equals 10 to the x, though, watch what happens. It shoots up a lot quicker. It's stretched up. So in this case, the bigger the base, the quicker it is to increase. All right, and so, you know, your base like that is going to shoot up quick. But if I have a base that's a fraction, right, instead of 3, I have it as 1/3 to the x. You know, you might think, well, it goes up slower, but not really. Watch what happens with that one. If I put in 1/3, so 1, let's use parentheses, 1 divided by 3, and raise that to the x power. All right. So this one comes in, increasing, going up, and the 1/3 x actually got flipped around the x-axis. The reason for that is laws of exponents. This is really 3 to the negative 1 to the x, which is 3 to the negative 1 is 1/3. This becomes 3 to the negative x, and we said 3 to the negative x is a reflection about the y-axis. So the fraction is going to flip it around the y-axis.